Good morning everyone, I'm Hafiza. I'm studying BTech in Srinivasa Ramanujanath Institute of Technology under the stream of Electrical and Electronics Engineering. These are the topic of Faraday's second law of electromagnetic induction. We are going to see in the presentation ahead. Now I'm telling about Faraday's second law of electromagnetic induction, and these are the statement. Faraday's second law, also known as the law of induction, describes how a changing magnetic flux induces an electromotive force EMF in a closed loop of wire. The induced EMF in a coil due to change in flux linkages is directly proportional to rate of change of flux linkages with respect to time. And this is mathematical representation. Epsilon is equals to minus n into d phi by dt. And some picture to related Faraday's law equation. And here ammeter to flowing the currents, and middle part is coil, and these lines are magnetic lines, and this is mathematical representation and detailed. Epsilon is equals to minus n d phi by dt, and epsilon is the induced EMF, units are volts. N is the number of turns of the coil, and phi is the magnetic flux in Webers. D phi by dt is the derivative with respect to time, rate of change. Now I'm telling conservation of energy. The conservation of energy is ensured by the law in the following ways. And first one is energy transfer, energy conversion, and Lenz's law. And transforming energy from the magnetic field to electrical circuit field, and converting energy between magnetic and electrical forms, and opposing changes in magnetic flux to maintain energy balance. And these are the Faraday's second law ensures conversion of energy in electromagnetic induction by relating the induced EMF to the rate of change of magnetic flux, showing that energy is converted between a magnetic and electrical forms. And some picture is to related to conversion of energy, and this is two magnets, and one is north pole and one is south pole, and between part is right hand thumb rule, and this is field, and this field and this field, and middle part is induced current, induced current flows, and this is this finger is motion, and this finger is field, and this finger is induced current. And third, conservation of energy equation. Input energy is a mechanical is equals to output energy is electrical. AU mechanical is equals to AU electrical. Substituting Faraday's second law, AU mechanical is equals to epsilon L delta T is equals to minus N into d phi by dt I AT. And simplifying, AU mechanical is equals to minus N I delta phi. And this is equation shows that mechanical energy input equals to electrical energy output. Energy is conserved with no net creation and description, and these are the example and applications. This fundamental principle has applications in the generators and electrical generators, motors, transformers, wireless charging systems, and inductive heating systems. And these are the examples and applications, and other electrical devices. And now I'm telling about conclusion. After conducting all experiments, Faraday finally concluded that if you related motion excreted between a conductor and a magnetic field, The flux linkage with a coil changed, and this change in the flux produced a voltage across a coil. Thank you so much for giving the opportunity.